Good day, sir. I am Kathleen J. Salazar. In this subject, statistical biology, I have learned that the word statistics is from the Latin word stesta, which means a person dealing with affairs of the state. It was really called state arithmetic. State arithmetic, tabulating information about citizens of a state for census, data, taxation, and war planning. Example, Roman Empire 117 AD, Roman coins, and Roman centurions. So what is statistics? Development in statistical has historically come from insurance, the need to predict disease body counts, shipwrecks, and the chance of privacy when exploring, astronomy, theory of error, biology, the need to create better crops or theory of inference, brewing, the guess for the perfect beer, or theory of or sampling theory, gambling, probability theory, war, predicting the outcome of a war before declaring it. When we say biostatistics, is the application of statistical principle in medicine, public health, or biology. There are two main branches of statistics. There are descriptive statistics and inferential statistics. Other one is focused on summarizing and communicating information about a group of numbers or data, are used to summarize, organize, and simplify data. The other one, drawing conclusion based on the data collected. In short, statistics are about summarizing and answering questions based on data. Observation, information in the environment, are usually based on individuals. A measurement or datum is a single observation. The term score is also commonly used in the data. Data are a collection of scores. So, population is the set of all individuals of interest. Population are often so large that it is impossible to obtain measurements from all the individuals. Example, population. All population, all individuals with schizophrenia. All people who take daily vitamin supplements in the US. All hepatitis B vaccinated health professionals. Some population are infinite or hypothetically they cannot be measured. A sample is a set of individuals selected from a population. We usually mean samples to be representative but not biased. Sample should be representative and generalized. So we're going to parameter and statistics. So when we say parameter, it describes a population, whereas a statistics describe a sample. So we use statistics to estimate parameters. So example, a sample of rumans. Number of malaria associated, that's from a sample of rumans. A population of rumans. Number of monthly malaria associated deaths of the ruman population. So generally, Greek letters denote parameters and Roman letters denote statistics. So example, when this symbol is used to describe the population average or mean, and then this symbol describes the sample average or mean in the behavioral sciences. And this it is called a X bar. It describes the sample average or mean in medical statistics. As I said earlier, inferential statistics are used to conclusion based on the data collected and making predictions that go beyond the immediate data. Sampling error. When we say sampling error, it is the discrepancy between the sample statistics and the true population parameter in estimating. To reduce sampling error, use a sufficiently large sample. Use random selection, selecting individuals from the population of a random of your sample to create an unbiased sample. Note, we can only prove something if we can measure the population. So let's go to the variable and constant. When we say constant, it is a character that is fixed across conditions. Example, the state of country in which you are born, genotype, fingertypes, and etc. When we say a variable, it is a characteristic that changes across condition. The constant is a characteristic that is fixed across condition. The variable, it is a characteristic that changes across condition. Example of example of variable is salary, marital status, white blood cell count, respiratory rate, and etc. In an experiment, the independent variable is the one that is manipulated, whereas the dependent variable is the one that is observed. To make an inference, we manipulate a variable of interest. It is the independent variable, and observe the effect on an outcome variable. It is the dependent variable, holding all other variables constant. So this is all I have learned in this subject, sir. So that's all.